Hello everyone and welcome back to another video. This is video 9.2, the second part of this videos that we're doing on heterogeneous integration. In part 1 we talked about the introduction to HI, and we talked about the interconnections and why they're so important for HI, and today we're going to be focusing more on the package materials and taking a little look at what the future of HI looks like. So thanks for joining me. My name's Alonso and let's get on with the video. So the first thing we need to do is look at the what we need from the materials, because not every material will work for any application. So we need to make sure that the materials we pick match the properties that we need from them. One of the most important things that we're going to need is high power capabilities, especially as we move forward with technology. We're going to need materials that can withstand and can perform under high power conditions. And as we all know, with great power comes thermal issues. So we need materials that can handle a lot of different temperatures, that can have, a wide range of coefficient of thermal expansion. Uh, Parameters like thermal conductivity or operating temperature are very important to make sure that they can perform under all of these situations. And we see over here that different materials have different, CTEs, and that not all of them might be valid for the application we're looking at. And we can also see how in recent years some components like power amplifiers get really hot. This is the heat flux in watts per centimeter square, and power amplifiers have a higher heat flux than the sun's surface. So definitely really hot, definitely a lot of heat being dissipated, and so we need materials that can deal with those kind of conditions. And other things that we need to look at is we need materials that are low cost, so the end product can be affordable. And other parameters that we need to look at are like fracture toughness. We need to make sure it has the right modulus, breakdown field strength, and interfacial adhesion. Those are all important parameters, and make sure that we get them right for the application we're using our materials for. So, what applications do we use each materials for? Well, uh, typically, each part of the package will have different materials. Um, and so, for example, in the lead frame, most commonly we use alloy 42 or Inconel, but sometimes copper can be used as well. For the encapsulant, we use epoxy, silicon, or polyamides. For the die, usually silicon, but silicon carbide can be used as well. In terms of the die attach, it's usually polyamides used. For the substrate, usually we use organic laminate materials. For the interposer, this is a topic we've covered before and mentioned several times. It's usually silicon, but it can be a glass or organic interposer as well. In terms of dielectrics, we can look at oxides, semiconductors, polymers, ceramics, composites. And in terms of the interconnects, we want conductors, so we'll use copper or gold mainly. And copper has been overtaking gold because it's cheaper and also a really good conductor. But sometimes we can also see silver or aluminum, especially on applications that are not so high end. However, all of these materials, and especially as we come up with new materials, those bring new challenges. And so, what are some of these challenges? Well, one of the bigger ones is obviously during manufacturing. The difference in the CTE during the high temperatures can provoke stress, can and create stress in the chip and the materials, and this can lead to warpage or or different things. And so, temperature management, warpage, those are very key components to fix and to try to solve during the fabrication process. We also have some resilience and reliability issues. Like after a while of usage or under certain situations, materials can develop corrosion, they can grow intermetallics, or they can get cracked under stress. So obviously this leads to the malfunction of the chip. So we need materials that can resist these things or be better at them. We also need to look at the security risk for materials. So, if we have a malicious entity that tries to perform a hardware attack on the chip, we need to make sure that we're resistant towards that. So some of the things they could do is they could potentially change the material recipe or the production parameters, and this can lead to failure or malfunction. And an example of that would be if they change the parameters of fabrication. Maybe the copper in the TSV could develop voids, and this can be hard to detect, and eventually this would lead to malfunction. So we need to be wary and careful of that in the future as well. And then the last thing to mention is that the perfect material doesn't exist. Like I've said before, Each materials will be good for different applications, but it's not like we have a one size fits all kind of thing with materials. We'll need to really make sure that we choose carefully which material we pick. So materials, why are they so important? Why are they uh, really relevant to HI? Well, first of all, they're kind of a bottleneck. They're kind of like a keystone to HI. Further HI innovation depends on the advancements in materials, and these advancements could bring improvements like power, performance, area or density, and cost, which obviously those would make the chips a lot more affordable. They would make them better, more efficient, and definitely take us to the next era of chips. Materials also enable the usage of new technologies, like for example, new bonding technologies. We mentioned hybrid bonding in the previous video, and they can also help create smaller devices. For example, this picture up here, these are nano inks, and basically you print the material onto the chip directly, and these can really help bring chips to a nanoscale, and make smaller devices. Another key point, and very important point to remember about materials, is that they set the limitations for the IC physical properties. So if and this is kind of like a team race. So if you go at the speed of the slowest racer. So if one single material cannot perform under certain conditions, then your entire chip cannot perform under those conditions, and then your chip is no good. So we need to be aware that these materials are the ones that set the physical properties for the whole chip. So that's something to be careful of, and why they're so important, and why we need to pick the right materials. And then finally, uh, research in materials is not only applied to ICs. It's not only applied to the semiconductor industry. They can be applied to really any field in technology out there. And one example that comes to mind would be, like solar panels. Solar panels also use some types of semiconductors, so they have a bit in common. But then they also use things like, encapsulants or adhesives and things like that, which we also use in terms of the packaging for ICs. So reaching new and developing new materials for HI can benefit not only the semiconductor industry, but also many other technology fields out there, and that's part of the beauty of it. So where do we think that HI is going? Where do we think we're heading towards? Well, um, first of all, there's been a lot of talk about 2D materials, and the new developments, and everyone's probably heard about graphene, but there are many other 2D materials. We can see them in this little wheel up here. So depending on which type of material we want, we have different options for 2D materials, and this can really help bring the scale of the chips down and make them smaller. Um, and this could be really important in the future. Another big point is that as we develop AIs, we can get AIs to design the materials. And this might sound crazy, but they can probably get better at it than we are. So we can probably set some parameters, or try to um, get the perfect material, or not the perfect material, but the best material and the best fit for the right application. And AI can really help us get there. uh, with new technology, we'll also probably have better switches, better transistors, conductors, bonding, just overall better and more efficient technology, an improved version of the technology that we have nowadays, with the future. And there's also been a lot of talk about monolithic 3D ICs, which seem to be almost like the next step into packaging. And there really is a big focus and a big shift towards 3D architectures, especially as they become more viable, as they become more affordable. Um, then 3D architectures really support all of the high end applications that they want, but they might even be used for not so high end applications once they become easier to reach and easier to manufacture. So really a big focus on 3D in terms of the whole packaging industry. And then finally, as always with these things, with technology and with packaging and ICs, with new times and better technology, we achieve a higher density of interconnections, density of transistors, density of chips, density of functionality, and we all of these lead to higher efficiency, higher bandwidth, and better performance. So that's kind of what we have in store, what we can expect from the future of HI. So let's do a quick overview of the entire topic that we covered in the two videos. So heterogeneous integration, uh, it's integrating separate components into a higher level system, and this really seems to be the next big step in packaging. Once we get this figured out, we'll have so many new opportunities. Chip developers will have so many new ways to try to implement their systems, and this is exciting. This is a big opportunity, and definitely something to look out for. Another important thing to cover is that we especially focused on interconnections and materials, which there are definitely two key components to development of HI. And both materials and interconnections, they enable the current technology, but also the development of newer technologies is now leading research in these fields, and so it's kind of like a reciprocal kind of like the technology enables the new packages and the new chips, but also new designs for chips that require better materials, better interconnections, lead the research in these areas, and so the whole system moves together and the whole system benefits from each other. Um, Another thing to take into account, however, is that with all of these new developments, new technologies, uh, they also bring new challenges and they bring new reliability and security issues. And so we need to be aware of those. We need to know what they are so we can work towards fixing them, and hopefully have a safe and reliable way of using all of this new exciting technology. Um, and then finally, in terms of trends and in terms of the future, it really seems like 3D packages will be the big thing, both with monolithic ICs, hopefully newer technologies, better heterogeneous integration. It seems like it's moving in a vertical direction, going up, and yeah, it's really exciting, and hopefully it brings a lot of new opportunities for everyone. So that's it for our packaging or for our heterogeneous integration two couple videos. Hope you guys enjoyed. Hope you guys learned a lot. If you haven't seen the first video, I highly recommend you check it out because we introduced the entire topic and we talked about a couple of interesting things. But yeah, thanks for joining me today. Hope you guys enjoyed the video, and I'll see you in the next one. Bye bye.